Hello students, welcome to the maths class. Today in this video I am going to complete this chapter continuity and differentiability of functions. Exercise 7. New in this exercise today you are going to study differentiability at a given point. Second, relation between continuity and differentiability. Three parts of this exercise I completed in my last videos. Now this is fourth part, and in this part this chapter will be completed. So what new thing you are going to study? Differentiability of a function at a given point, and relation, what is the relation between continuity and differentiability. First of all, I will tell you what is differentiability. A function is said to be differentiable at x equals a, at x equals a. Fx, suppose function is given fx. Fx is said to be differentiable at x equals a if LHD is equal to RHD, and they exist also. What I told you, one more time I am telling to you. What is LHD, what is RHD? First you listen. LHD means left hand derivative, RHD means right hand derivative. LHD means left hand derivative, RHD means right hand derivative. As in case of continuity, LHL and RHL you studied left hand limit and right hand limit. In the same way, left hand derivative and right hand derivative. What is the method to find left hand derivative and right hand derivative? I will tell you. If at x equals a, left hand derivative is equal to right hand derivative, then you can say function, given function fx is differentiable at x equals a. Okay. So left hand derivative is also denoted by L f dash a. It is left hand derivative. One more time you see, LHD at x equals a is equal to L f dash a. RHD at x equals a is equal to R f dash a. Okay, where a is any real number, where a is any real number. Function, you know, fx equals, suppose it is given x square plus 2, suppose it is given function. You have to show this function is differentiable at, suppose that at 2 you have to show. So in this case x equals 2 will be there. So you will calculate LHD, you will calculate RHD. If both exist, and they are equal, then you can say function fx is differentiable at x equals 2 or at x equals a. So one more time I am telling to you, you have to find LHD and RHD. They must exist and they must be equal. If it is so, then function will be derivable or differentiable at x equals a. Now how to calculate LHD? LHD, left hand derivative at x equals a, you can calculate limit h tends to 0 f a minus h minus fa upon minus h. You have to keep in the mind. And RHD, right hand derivative, r f dash a is equal to limit h tends to 0 f a plus h minus fa upon h. Now you can see this one is for LHD, this one is for RHD. What is f a minus h? For LHD a minus h will come, for RHD a plus h will come. In both the cases minus fa will be there. In LHD, in denominator minus h will be there, in denominator plus h will be there in case of RHD, right hand derivative. So you keep in the mind, in case of left hand derivative, in the denominator minus h will be there. In case of right hand derivative, in the denominator plus h will be there. In numerator f a minus h will be there. And in case of LSD, in case of RSD, in numerator f a plus h will be there, and minus fa in both the cases it will be same. Now how to calculate, I will tell you in the question. Okay, now what is second point is, what is relation between continuity and differentiability. So you have to keep in the mind, if a given function fx is continuous c for continuous, then it may be differentiable or may not be differentiable. It may be differentiable, may be, or may not be. May not be. May not be differentiable. D. I have written D for differentiability. So if function is continuous, function may be differentiable or may not be differentiable. But if function is differentiable, fx equals differentiable, then it must be continuous. It will be continuous. So function is, if it is differentiable, then 100% it will be continuous. But if function is continuous, so it may be differentiable or it may not be differentiable. Only this is the relation between continuity and differentiability. So first point we are going to study. There are 4 questions in your book. Only 4. 24, 25, 26, 27. So out of 4 questions, 2 questions I am explaining. You can see here. Exercise 7, 25 question I am taking. Difficult question I have taken. Show that the function fx equals mod x minus 1 plus mod x plus 1 for all x belongs to real number is not differentiable at point x equals minus 1 and x equals plus 1. You have to show this given function is not differentiable at 2 points, which is x equals minus 1 and x equals plus 1. How to show? First of all, modulus function is given, and I told you modulus of function can be converted into piece functions. How to convert into piece function? What is given in the mod, you put that equal to 0. So in first mod x minus 1 is equal to 0, you put x equals 1, it will come. In second mod x plus 1 is equal to 0, you put x equals minus 1 will come. So two values of x equals 1 and x equals minus 1 you have got. Now with the help of these two values, you will convert the given function into piece function. How to convert? When x is less than minus 1, when x is greater than minus 1, when x is less than 1, when x is greater than 1. So 4 conditions will come. I have written here 3 conditions because one condition, common condition I have taken. Now you can see here, when x is less than minus 1, you can see when x is less than minus 1, first term you see mod x minus 1. So mod x minus 1, inside the mod negative number will come when x is less than minus 1. So first term will be negative. Second term also, when x is less than minus 1, mod x plus 1 will be negative. So that's why I have taken negative, because suppose x is less than minus 1, minus 2 you take. So mod x minus 1 will come minus 2 minus 1. Minus 2 minus 1 minus 3. Mod minus 3. And mod minus 3 minus 3, you know very well. So mod of negative number is negative number. It is the definition of mod function. In the same way, if you are taking x mod x plus 1 and putting the value minus 2 plus 1, so mod minus 1 will come, mod minus 1 minus minus 1. So negative, again negative. So you can see, that's why I have taken for x is less than minus 1, first term is minus x minus bracket start x minus 1 minus bracket start x plus 1. In the same way, when x is greater than minus 1 or equal to minus 1 but less than 1, So first term will be negative, because when x is equal to 1 is equal to minus 1, so inside the bracket negative number will come, minus 2 will come, so that's why it is negative first term. And if it is less than 1 but greater than minus 1, less than 1 greater than minus 1, 0 you can take. So when 0 is there, then in first bracket 0 minus 1 again negative it will come. So that's why it is negative, but second term will be positive for minus 1 and greater than minus 1. In the same way, when x is greater than 1, less than 1 here you have included in second step. When x is greater than or equal to 1, then first term will be positive and second term will be positive. By simplifying, you are getting the piece function fx equals minus 2x when x is less than minus 1, fx equals 2 when x is equal to minus 1, greater than minus 1 and less than 1, fx equals 2x when x is greater than or equal to 1. So this is the function. Now you have to show this is not differentiable at x equals minus 1 and at x equals 1. So I have written here for the differentiability at x equals minus 1. LSD I am calculating. LSD can be written as L f dash minus 1. Limit s tends to 0, f minus 1 minus h minus f minus 1 upon minus h. I told you in the starting of the video. So now what is this f minus 1 minus h? In the function, in place of x you have to put minus 1 minus h. Again I am telling to you, in the function, in place of x you have to put minus 1 minus h. Now what is the function in which we have to put minus 1 minus h? Now you are taking LSD, left hand derivative, at x equals minus 1. So the function which is for the values of x less than minus 1, that function you have to take. So you can see for less than minus 1 function is minus 2x. So in minus 2x, in place of x you have to put minus x minus 1. You can see minus 2 into minus x minus h, minus 1 minus h, sorry, minus 1 minus h minus f minus 1, value of f minus 1 you can see equal to x is equal to minus 1, value is 2. So you can see here I have put here 2. Now you simplify. When you simplify, you are getting limit s tends to 0 minus 2. So left hand derivative is coming minus 2. Now you can see right hand derivative. Right hand derivative RSD at x equals minus 1, limit s tends to 0, f minus 1 plus h minus f minus 1 upon h. Now in the function, what is the function fx? What is the value of function fx for x is greater than minus 1? For x is greater than minus 1, you can see here x is greater than minus 1. You can see second step. So this is the function 2. You can see here directly 2. And x is equal to minus 1, that is also 2. So that's why I have written 2 minus 2 upon h, 0. So RSD is coming 0. So LSD is not equal to RSD. So function is not differentiable at x equals minus 1. Now for the differentiability at x equals 1, you can see LSD, left hand derivative, limit s tends to 0, f1 minus h minus f1 upon minus h, just before I told you. Now for what is the function for x is less than 1? For x is less than 1, you can see this is the function x is less than 1, 2. So you can put 2 here. And for f1 I am putting the value in 2x, 2 into 1, because for x equals 1 function is 2x. So 2 into 1. So final answer is coming 0 upon minus h. Limit s tends to 0, 0 upon minus h. Its value is 0. Left hand derivative is coming 0. Right hand derivative you calculate. RSD, limit s tends to 0, f1 plus h minus f1 upon h. So you can put in the function value for x is greater than 1, function is 2x. So in 2x I have put 2 into 1 plus h minus 2 into 1, because for x equals 1 function is 2x. For x equals 1 function is 2x, for x is greater than 1 function is 2x. So that's why I am putting 2 into 1 plus h in place of x, and here functional value 2 into 1 upon h. Finally you are getting limit s tends to 0 2. RSD is 2, and what was LSD? LSD was 0, you can see, and RSD is coming 2, you can see. So LSD is not equal to RSD. So function is also not differentiable at x equals 1. So students, you have seen how to show the given function is differentiable at a particular point or not. So I have showed you LSD you calculate, RSD you calculate. If both exist and they are equal, then function will be differentiable. Otherwise, it will not be differentiable. In our question, at x equals minus 1, LSD, RSD, they were not equal. At x equals 1 also, LSD, RSD were not equal. So it means that function is not differentiable at both the values of x. Now 27th question I am taking. Show that fx equals mod x minus 20 is continuous at x equals 20 but f dash x does not exist at x equals 20. F dash x does not exist at x equals 20. What is the meaning of this line? F dash x does not exist at x equals 20 means fx is not differentiable at x equals 20. So you have to show this function is continuous at x equals 20 but not differentiable at x equals 20. So for continuity, you know very well. First of all, I have converted into piece function. X minus 20 equals 0, x equals 20. So when x is greater than 20, so x minus 20 positive term will come. When x is equal to 20, then 0 will come. When x is less than 20, then negative term minus x minus 20. So it will become 20 minus x. Now for continuity at x equals 20, three things you have to find. In last videos I told you. Functional value at x equals 20, 0 it is given, you can see here. When x equals 20, functional value is 0. LHL, left hand, limit. Limit x tends to 20 minus fx. What is the function for x is less than 20? 20 minus x. So you put 20 minus x. I have put here. Now in place of x, 20 minus h can be written. So by simplifying, you are getting limit s tends to 0, 20 minus 20 plus h. Limit s tends to 0, h means 0. H equals 0. RHL, right hand limit. Limit x tends to 20 plus fx. For x is greater than 20, fx is x minus 20. So limit x tends to 20 plus x minus 20. Now put the value of x 20 plus h, s tends to 0. After simplifying, you are getting 0. So LHL equals RHL equals fx at x equals 20. Functional value f20 is also 0. So function is continuous at x equals 20. Now for the derivability or differentiability at x equals 20, LSD at x equals 20, limit s tends to 0, f20 minus h minus f20 upon minus h. Now in the function you put 20 minus h, 20 minus 20 minus h, f20 is 0 upon minus h. Simplify it, limit s tends to 0, h upon minus h, minus 1. So left hand limit is coming minus 1. Now RSD you calculate, limit s tends to 0, f20 plus h minus f20 upon h. In the function, when you put 20 plus h minus 20 minus 0 upon h, h upon h, it is coming 1. RSD is coming 1, LSD is coming minus 1. Both are not equal. So fx is not differentiable at x equals 20. So you have seen at x equals 20, function is continuous. but not differentiable. Just before second point in the starting of the video, I explained second point. If function is continuous, then it is not necessary, it will be differentiable. So this is the question to explain this point. At x equals 20, function is continuous but not differentiable. So remaining two questions, two I have explained. Remaining two questions you can do based on this concept, and after this chapter is over, I will start the revision. Tomorrow in next video I will start the revision. So if in these two questions you have any doubt, then you can ask. So thank you and have a nice day.